Hi, I'm Christopher McNabb. I'm a database and application administrator in the Division of IT in the Enterprise Systems Group at Virginia Tech. I'm primarily responsible for our cloud-based Postgres, Redshift, and Snowflake databases, as well as our Vault implementation. I've been at Virginia Tech for 24 years, the first 18 as a systems administrator, and the last 6 as a databases administrator. In 2018, my group was using a shared KeyPass file for secrets management. It worked mostly, but had issues. For example, if 2 people were editing the file at the same time, the person who saved last won. The person who saved first, their secrets would get overwritten by the second person, and that led to some problems and some confusions at times. Secrets can also be hard to find because we really didn't have a defined way to name them, so that they would basically, you would have to search to find what you were looking for, and that could take some time and was kind of a problem at times. And because of that, duplications also were not too uncommon, because once a person found a secret from another group that they needed, they would save it into their own area, and so there would be 2 copies of that secret, and if one got changed, the other one probably wouldn't, and of course that led to issues also. And key names weren't consistent. Password, for example, was spelled PASSWORD, or PASSWD, or PSWD. It really was kind of the luck of the draw and who wrote the secret that determined how that would be. And there were no access controls within the shared file, so any group could read any other group's secrets, which was also a problem. After looking at a lot of different options, we chose Vault as a replacement for KeyPass. Because 1, it supports a wide range of authentication methods such as AWS IAM, app roles, user pass, LDAP, OIDC. Just about everything we used, we could authenticate to Vault using it. It can manage dynamic and static database roles and credentials, and can handle password rotation, which is a very useful thing. It has a very well-defined API, so scripting is really easy with it and very powerful. And it has really good access control policies, and we make a good use of those to make sure that people follow our naming standard as much as possible. So after a period of testing Vault, we migrated in bulk all of our secrets from KeyPass to Vault using a homegrown utility to do that. A year later, Vault worked well mostly, but because of growth, there were still some issues. 1, secrets were still hard to find because we didn't yet have a naming policy. There was still some duplication for the same reason. It wasn't obvious who maintained a secret, so getting permission to use it or to change it was sometimes difficult. And key names were still not consistent, which made automation more difficult. We needed a solution for the issues, and that solution would be a standard way of naming secrets and their fields. Vault administrators and development leads in collaboration set goals for what that standard should do. It should simplify determining where a secret is stored. It should show who is responsible for maintaining the secret, that is, who can change that password where it is used and who writes it into Vault. And that's based on an LDAP group membership. It should make duplication unnecessary. There should only ever be 1 copy of a an individual secret within Vault. It should specify how keys within a secret should be named, and it should simplify how access control policies are written. A naming standard based on these goals was developed, approved, and published in our department wiki. It specified the KV secrets are organized by who manages them and what they access. And the key path looks like this, with the department, division, manager, usage, type, what, environment, and secret. The department division is the mount point, and it's the organization that owns the secret. Having a separate mount point will make it easier to switch to namespaces in the future. Manager is the LDAP group whose members are able to update the secret where it is used. And we tie that basically in our policies to a Vault group alias for our LDAP authentication. Usage, if this is either operations or internal, and if the secret is used by applications, it is operations. If it is used by people to access a shared resource, it is internal. Type is if it's a database credential, an application login, or something else. What is the database, application, or something else that is actually being accessed? The environment is one of either production, test, or develop. And then we get the secret itself, which is the name of the actual secret, and that should be closely related to the username, service, or whatever is being accessed. If it's a Vault dynamic or database role, the name is determined by the database instance and database username. Some examples, we have dit.es/es.dbaa/internal/application/dominoes.com/all/vtesdbaa. That tells me that the secret is owned by Division of IT Enterprise Systems. It's managed by the Database and Application Admins Group. It's an internal secret for the dominoes.com application for all tiers, all environments, and it's for the user vt-es-dbaa. The next one, dit.es/esdbaa database ops database snowflake develop ETL. This is again owned by Enterprise Systems. It's managed by the database subgroup of the DBAA team. It's an operational, so it's used by applications for a database, in this case Snowflake. It's for the development tier, and it's for the ETL user. The next one we have is a Vault managed static credential, where Vault rotates the password on a periodic basis. And it's our Postgres database server for the MyUser user. And the last one is a dynamic database role for our Oracle server for the your user user. So we also specify required keys, or what keys should be in the secret in our naming standard. Those are the username, which would be the username on the service that you're accessing, if there is one. One or more keys named as a type of credential, an SSH key, a password, or certificate, or something else with the value for that credential. A basic description of how that, of what the credential is used for. It might be like, the financial GitLab runner access to the secrets that its job needs. Just a basic description. And then a string describing how to use a credential, normally as a URL. For instance, Postgres : username at database : port / database, something like that. It should be copy pastable, and it should be directly usable by an application if needed. Then we have access policies that enforce how secrets are written. And this is an example policy. The first line specifies it for the dit.es path. The first plus covers both the data and the metadata parts of a KV2 path. And we don't use asterisk in this first part because we don't want to have unintended consequences by allowing too much. So we very specifically set path segments, and we only allow list. Once we're on the biggest one there, I think it's the sixth one, it allows full control of secrets at that path. It's very long, so it says that DIT Enterprise Systems metadata or database team can manage operations application secrets in the develop environment. They can create, update, delete, read, list, and patch. And then we use required parameters to say that each secret must have a username, a URL, a description, and a password, which those are the keys that we require. The last one says anything longer than that, deny it to everybody. No list, no read, no write. It's just permission denied all the way down. So in summary, a well-defined and published naming standard can help you improve security by making it easier to write policies to allow people to access the secrets by having a known path structure. It also makes it easier to find the secrets and who manages them if you need to. Thanks.